Okay, so here's where we're at today. Yesterday we spent some time talking about how to get the line to appear on a calculator, right? So we discovered a little bit about what y equals mx plus b really means. So slope-intercept form, go ahead right above this, just kind of write y equals mx plus b. And let's remind ourselves the purpose of this whole section. The section that we're doing right now consists of 3 parts. All of them, all I want you to do on part 1, part 2, part 3, thank you, is graph it. So this unit, or this section of this unit is graph it. 3 different ways. Hey, if you don't remember slope-intercept form, make a table. It works every time, okay? But we're going to find today, right here, that making a table is kind of a lot of work. You could make some mistakes in your computation, that we're going to learn the shortcut today, okay? So I want you to kind of write a little arrow here and point to the B, and that's going to be where you begin. And then the M is going to be where you move from your beginning point, okay? Yeah.
So I know M means Monterre, but
yes.
What does B mean?
I have no clue. That's a great question. He said the question was, we talked about M stands for monter. It's a French word that means to climb. What the heck does B mean? That's your homework. Somebody find out for me why they use B as the beginning value, because it's not because it's the beginning. I can't imagine it's got to be something more to it than that. Good question though. All right. So what I need you to really know is that I want you to think about what a line is. On a graph, with no equation around, if I just give you a graph and say, hey, I'm going to draw a bunch of lines on this graph. I'm going to draw this one, I'm going to draw this one, and this one's horizontal, and this one's vertical, and this one has a little bit of a slant. There's an infinite number of lines that I could put on every graph. An infinite number, okay? And what you need to know is that each one has a different name. Just like there's tons of people on this planet, and each one has a different name. I know they sometimes share the same name, but each of you has your own, genetic makeup or your own fingerprint, right? So you have your own name. Each line has its own name. So it's up to you for Unit 4 to be able to know the name of the line, right? So the name of this line is y equals negative x plus 4. But what does that look like on a graph? That's all I need out of you for 4-2, okay? So let's start by kind of taking a look at number 1. So let's look at y equals x plus 2. So yesterday, when we graphed this line right here, and I said to you, hey, remember that parent function? Remember that parent function that says begin at 0? And go up 1 over 1, up 1 over 1. That was our parent function, and that was y equals x, right? And then I gave you this line, and you had to match them. So the first thing you did was, hey, where does Mrs. Z want me to try to get that line to touch the y-axis? And you see that it's at negative 2? So right away, you hopefully knew, so that means I got to put a minus 2 at the end. Okay, awesome. I got that part. Let me look at the rest. Well, it's not going up from left to right. It's going down from left to right, so that means it's a negative slope. Okay, I got to put a minus 2 at the end, and I got to put a negative slope. Now what number do I put in front of the slope? That has to do with the movement along the line, right? And if you were very precise yesterday, you actually, without grid lines, tried to calculate the slope exactly instead of guessing. So as I'm looking at this, I say down 1, over, could be 2, maybe 3, either one. And so when you saw the equation, there was your minus 2, there was your negative, and the number in front of your x is your slope. So we're going to tie all of this that we learned yesterday. We spent a half an hour on these calculators yesterday, right? And so today we're going to see what that, how that equates to putting it on a graph. Because A, you're not always going to want to make a table to graph a line, and B, you're not always going to have a calculator to graph a line either. So here's the shortcut, and it's something you're going to need a lot. So I asked you to have 2 different color highlighters. I'm just going to use orange if you happen to grab an orange. If I need to know where to start, okay? If I need to know where to start, where's a good place? What's the only thing? I know that the slope is up 1 and over 1. But where do I got to begin? Yeah. At 2. So color coding sometimes helps. So I want you to just kind of highlight the 2 in whatever color you're choosing. If it's not orange, that's okay. If you'd rather it match me, that's fine. Because that means that I'm going to put a point right at 2. That's my beginning value. Okay. So now, we're also going to grab rulers in a minute. But basically what this means is, by default, how many points do you need to make a line? Can I make a line right now? I mean, I can, but it's kind of like when you go to make a line, what do? You put your pencil on the point, you put your ruler right up against it, and then you kind of do this. And right now, my ruler's kind of looking for a second point to match up with, right? There's nothing out there right now. How do I get it? I have to look over at what? The slope of the line. And the slope tells me where to move. So, keeping your pencil on the beginning value, what does this mean? What does a x slope mean? It means I'm going to rise up 1 and run right 1. Ooh, try to say that fast 3 times. Rise 1, run 1. Okay? Here's my advice that's going to be to you. The best thing you can do is starting here, either move up and run right or move down and run right. 95% of the time, you're going to run to the right. There are going to be a few times you're going to run to the left, and I'll show you when, but you're going to want to try to avoid that. So I'm literally just like plotting another point. From here, and this is where you're going to use your second color highlighter, and I'm just going to go up 1, right 1. And then there's my next point. Okay? And so, stop. Normally what we do, watch, I just kind of want to show you. So normally what we'll do is we'll take those and we'll connect it and we'll make our line. But I want to show you about being precise, okay? If you want to grab a ruler right now, or if you have the edge of your planner or something, that's fine too. You can go up there behind the milk crate there. So as you're getting that, I want you to think about this. If being precise is really important, if I'm looking at my line, I'm actually wasn't very precise. Because watch, if you know you did the true slope, then what should be the case? If I keep going up and right, up 1, right 1, up 1, right 1, I should continue to land on the line, right? If I get really close and I keep going up 1, it doesn't, yeah, actually I did it way too good. No, it works down here. Up 1, right 1, so far so good. Okay, up 1, right 1. But as I start to move down a little bit, I want you to keep this in mind. This is going to save you. This is something that I'm giving you for Unit 5 when it gets here. You'll thank me for it later. If I keep going up 1, right 1, up 1, right 1, I should continue to land on the line. So what's the opposite of going up and right? Going down, which is a negative, and left. Do those both mean positives? Yes. So watch what I do. As I do that, and from here I go down and left. Ooh, already I can see something's up. Down and left, down and left. What's happening? You know what just happened? Human error. Do you know what that means? It means when I put my pencil lead here and I put my ruler up against it and I went to connect these 2 points, my ruler was maybe a millimeter or a half a millimeter off, tilted the wrong way, right? So maybe I don't want to just do 2 points and then connect those. Maybe I want to fill my graph with points, right? And so maybe I put these 2 because these 2 are the points I'm going to look for. These are the most important ones. Did you know where to begin? Did you know where to move? The rest of the points are going to be kind of little extra guideposts because look now. If I'm really precise, that should be my line. And if you don't put more points in Unit 5, you're going to get some questions wrong. Here's why. Because your line needs to be precise. Are we good with that? All right, let's try that again. Let's move over to number 2. And you know what? If you're going to use your highlighter, why don't we highlight that? So that kind of color codes where you went. It's the up and the over. So now where do I begin? At my starting point of positive 4. And this time, what's my slope? -1. And when there isn't a fraction there, did you ever think, oh my gosh, I actually want a fraction? Probably never in a million years you thought you'd say that. But for slope, you do. Because you want to know the rise and you want to know the run. So be very careful. The rise is a -1. So am I going to go up and right? No, I'm going to go down and right. Don't go left. Don't go left until I show you when you should. Down and right. And those are the most important points that I want to see. But before I draw my line, I want to make sure it's really good. And by the way, I'm showing you in blue this little stair. You don't have to do the stairs. And actually, the stairs kind of get annoying after a while seeing them. This is just to kind of teach you. So if what's the up, about same as going down and right, I could keep going to do what? Up and left. So once you have enough points to feel like you have a really, really precise line, and guess what? What are the best 2 points to connect right now, to use? This one and this one. Those are the ones I'm lining up, my 2 end ones. So that and that. You want to extend your line. You want to draw arrows because it is a continuous line. Are we good? Okay, there's a couple other things that are going to happen. Let's move to number 3. So as you have that line, go ahead and color code your slope. Your slope is down 1, right 1. So you can kind of see what those colors mean. All right, where do I begin for this one? -3. Go ahead. -3. I still don't have a slope that is a fraction, so let's make it a fraction. And now that's telling me to go what? What's my directions? Up and right or down and right? Up and right, because they're both positive. So from here, 1, 2, 3, 4, 5, over 1. You don't need to do, for teaching purposes, there's your 5, there's your 1, if you think you really need to see that. And guess what? Sometimes you run out of space. Sometimes the slope is so big that you just can't fit more than 2 points. We could see if we can fit another one. If I go up 5, I maybe run off the graph a little bit, but it would be there. I don't really need to go down this way because then I'm kind of off the graph. So sometimes 2 points is going to have to be enough. So I'm going to use this one, and that's a pretty steep slope, isn't it? Because we learned yesterday what happens when the number in front of x gets bigger. It gets steeper. So should that surprise you that that line's pretty darn steep? Probably not. Okay? Let's skip 4 for right now. That's our special case, and let's go right to 5. All right. Something happens here that's going to require a run to the left. And you're going to know it as soon as you plot that y-intercept and look at the slope. Go ahead. Where are you going to start? And I chose this one for the notes on purpose. Because when you start here, and then it asks you to move what? What's your rise? 9 down? I only have 1 down, and then I run out of graph. Shoot. So guess what? And I purposely put this problem at the bottom of the paper, too, because we ran out of paper. Because you know what some kids will do, and I've seen it? They'll do this. Down 9 over 5, and they'll use the whole other graph for this problem. There's a better way. And what is that better way? If you run out of room, and you can't go down 9 and right 5, here's what you're going to do. You're going to kind of visualize where that point would be. If I could go down 9 and over 5, it would be like right about here, which would mean to get to the other point, I shouldn't go down and right. I should go up and left, right? I want to show you this. If I go down and then right, isn't that the same as going up and then left? Aren't they both negative slopes? It's just the direction I chose. So this is the 5% of the time that, remember I said 95% of the time, up and right or down and right. You may need to go left sometimes. This is one of those times. So I'm going to go up 9 and 5 to the left, and there's my point. Don't go up and right, because if you go up and right, then you just made that slope positive, and it's not positive. It's negative. So that's where you're going to connect this point, match your ruler up, and you get your line. Okay? So please don't extend it more than like one grid line off the graph, because that will drive me nuts if it's 3 inches into the other problem when there's an easier solution. Okay? All right, so let's take a look at these special cases. These special cases that continue to haunt some of you. Is it undefined? Is it zero? Is it vertical? Is it horizontal? Guess what? I feel like I said it 1,000 times. If you don't know, what can you fall back on every single time? A table of values. If you can't remember which one it is, then make your table of value. Make all your y's 5. Do 2 points. That's all you need. Do 1 and 2 here. And plot it. 1, 5, 2, 5. Oh, okay, that's the horizontal one. That's what I thought. I just wanted to make sure. It took me like 5 seconds to do that. So instead of guessing, be really, thoughtful about it. Think about how you could figure it out. So then the other one would mean, remember we talked about an H. If you flip it upside down, it looks like a what? It could be a Y. So that's one way to look at it. The Y equals without the X means it's H, which is horizontal, and horizontal is 0. Or some people say, you know what, Mrs. E, you know how I look at it? I say, well, if it's a Y equals, then it can only touch the Y axis and not the X. Which would mean what about the X equals? That it can only touch the X axis and not the Y. So what kind of line do I need to draw right now? If it doesn't touch the Y, then it's parallel to the Y. And what kind of a line is parallel to the Y axis? A vertical, undefined slope. Okay? Whatever you need to do to help you think about that. Here's another way to look at the Y equals one. The Y equals 1 could be, well, okay, at least it's like Y equals. Somebody said, I don't see an X. Oh, so you mean there are 0 X's? Yeah, that's all Y equals 5 is Y equals 0x plus 5. And what's the slope in a 0x? Up 0 over 1. Up 0 over 1. And then this plus 5 is still your beginning value, isn't it? But I almost guarantee you're never going to see Y equals 0x plus 5. Because if there is no X, they're just not going to put one. Because guess what else? There's no Y, there's no A, there's no B, there's no anything. So they're not going to put that. But that kind of is a quick little way for you to at least see that. Okay, are we good? Flip it over. And I want you to get rid of, I need to redo this, but I would like you to get rid of the plus 3 that's there. I want to do one without a y-intercept. So just scratch it out, okay? And so when I go to put my orange dot, I don't see a number. So where do I start? 0. I had a kid once tell me, you should start at 1. And I said, why? And they said, because there's nothing there. And when there's nothing there, you put a 1. And I went, ooh, you're kind of half right. What were they thinking? When there's nothing there, meaning in front of the X, put a 1, right? So when there's nothing, and there is something there though, there's an X there. Do you even see an X on this one in terms of the second part? No. So there is something there. It's just a 0. Okay? So I know you have that 3 still there. That's frustrating, sorry. So that just means you have 2 options. When you don't see a y-intercept, you could put 0 if you want. Or you could just know what that means. Oh, it just means I got to start here? Because I don't see a number? Yep. And then everything else is the same. So from here, be careful, your rise is 1 and your run is 5. So does that make sense to you? And then do I maybe have room to fit one more over here? So instead of going up and right, what could I do? Down and left. And those are my 3 points. I'm going to have a nice, precise line because I'm going to use this point and this point over here, not these 2. However, when I check your test and there's a section that says, okay, I just had you make a table, part 2, don't make a table. I want to see your 2 points. These are the points that I want to see. I want to see if you began where you're supposed to begin and if you moved either one of those movements, one on either side of it, okay? All right, go ahead and try number 8. Be careful when you try number 8. What happens? Same thing that happened on the other side. I ran out of room. Notice it's at the top of the page. There's not enough room for you to go up 7 and over 1. And if you are, then you're like somewhere up here, which is not on the paper. So you don't need that point because you know another route. So instead of going up and right, I would do what? Down and left. Just know that. So I'm going to go down 7 and 1 to the right. And 7 is a pretty big number, which means the bigger the number, the steeper it gets. So does your graph look pretty steep? Yeah, it does. And I had somebody one year mix up, I actually have it happen every year. They mix up their rise and their run. And they do down 1 and over 7, which would be here. And then they plot this, this line that's not very steep. And then, I'm just going to go here. And then I say to them, 7, remember what we did on the calculator? When 7 got bigger, the line got steeper. Your line's not very steep. So there's all kinds of ways for you to check to see if you're doing it right. Okay, good? All right. So, remember how I said, hey, putting it in slope-intercept form, it's coming back. It's coming back in 4-2 and 4-3 and 4-4 and all of 5. So if we've not yet learned how to put an equation in slope-intercept form, you have to learn. You have to get y by itself. So if I want to get the y by itself, I need to subtract the x term or add it if it's a negative. I will tell you what I've seen more than anything lately. This is the step that most kids are skipping, and then this is what they're doing when they write it. They're writing negative 5y equals 2x plus 25, and then they're getting their slope wrong. Because if it's a 2x over here on this side, it's not a 2x over here. It's what? A negative, because you have to subtract it. It took me about a half a second to write that. Minus 2x, minus 2x. So now I'm not even done. I have to divide everything by negative 5, which gives me y equals. And what's a negative divided by a negative? Positive. So cancel it out. Your slope is 2/5. And what's your y-intercept? Be careful. It's a positive 25 divided by negative 5, which means I'm starting here. Do you realize the danger in graphing an equation that's not already in slope-intercept form? Because if you fail to put it in slope-intercept form correctly, do you even have a chance of getting the line right? No. Because if you forgot and you put a plus 5 here, where's your graph going to start? Right here. Where's it supposed to start? Down. So this step has never been more important. Watching all that. And so, again, I'm okay because all I have to do is go up and right. So I know I'm near the end, but all I have to do is go up 2 and right 5. It's all I can fit. That one's done. So it's just kind of hanging down here. Okay? Let's go to number 10. But I want you to change number 10 real quick to a plus in the middle. Okay? So now I need to get the x by itself, or the y by itself. That means I have 5y is equal to negative 3x plus 5. Divide everything by 5. That leaves me with what? Excuse me. A negative 3x divided by a positive 5. Yeah. Go ahead.
I have a question.
Yeah?
So, would you ever see y equals mx divided by cubed b?
You could, and it would just be having to play around with it to get it in the correct, you'd have to do some multiplying and undoing things. So this is going to be just negative 3/5. Positive 5 divided by another positive 5. Don't get fooled. Don't put 5. It's 1. Okay? And so now I start at positive 1. And I do what? What do I do from there? Down and right or up and right? Down, because your rise is negative. So I'm going to go down 3, right 5, And maybe I can even fit another one by going up 3 and left 5. And I have a more precise line to connect. All right, you with me? Got one more in you? Okay, let's do 12. Let's just do 12. All right. 12 is kind of unique because there's a 0 there. They can't just put x minus 2y equals nothing. And if there's nothing, they just put 0. Subtract your x from both sides. That leaves you with negative 2y equals negative x. If you want to put the plus 0, you can. It might actually complicate things later when you go to divide. So I would just leave it. Just one last thing to look at. So I'm going to divide both sides by negative 2. And I'm going to say y is equal to what? Be careful. This is the one most people got wrong on 4-1. It's 1/2. So this is actually 1/2 x. And what's my y-intercept? The origin. Okay? So, starting at 0, going up 1, over 2. So, is this so much nicer? And I mean, I could keep going up 1, over 2, up 1, over 2, down 1, left 2, down 1, left 2. I mean, I could fit a lot of these. Okay? They should all line up, and they should all be on the same line, except I just moved the ruler when you connect it. Are we good? Okay, so then what you're going to